A big welcome to everybody joining us today on the Ekahau webinar series. Today's episode is all around 6 gigahertz and how we can help you transition with a step-by-step guide on everything you need to think about and plan for upgrading to a 6 gigahertz network. And I'm going to pass it back to you, Dale, for a quick round of introductions.
All right. So today we have a special guest with us, Kevin Nanns. He is a network engineer in the public sector, also a phenomenal content creator, generally awesome guy. How are you doing today, Kevin?
Hey, that was a great intro, man. Thank you.
Yeah, glad to have you here. Then we have Matt Starling, our senior director of product marketing and ECSE. Then we have the fabulous Wireless Stu, who's our global director of community and customer engagement. And then there's Dale Tyler, sales engineer with Ekahau for the Americas.
Yeah, and you may describe me as generally all around not so much of a great guy. I don't know. But Kevin, maybe you can just tell some of the people on the webinar today a little bit about your social media following because maybe they haven't come across you yet, but I know you might be a bit modest, but I checked out how many likes you've got on one of your platforms earlier, and it was over 1 million likes that you've crossed now, right?
Yeah, thank you. I started about a year and a half ago now. And I was just creating content for network engineers, following like what I do and the things I enjoy doing, which is like labbing and trying to, create content about, I don't know, just my everyday life as a network engineer. And it's kind of taken off. I started as a hobby and now I've kind of turned it into a thing that I just can't stop doing. It's kind of taken life of its own now, where people actually follow me and actually like what I put out. So that's kind of cool. But I'm adjacent node everywhere. I'm on TikTok, Instagram, X, pretty much every single platform, which is exhausting, but I'm on every single platform. And I make videos about network engineering and what I do. And yeah, so it's really fun.
I can see in the chat a few people are finding your content to be really great from what I can see so far. And just me personally, I really enjoy watching your content because I love the perfect balance between education and a sense of humor. And some of the videos you've done, I found to be very funny. If you haven't checked Kevin out yet, go look him up on social media after the webinar, of course. You want to make sure you stick around for the live content from Kevin today. But yeah, go and check out some of his videos. Before we actually start the webinar today, we announced recently that we launched a public Ekahau Slack channel. We know that you love having the conversation in the webinar chat and just wanted to give you a platform and a place to continue that community conversation on after the webinars have finished. If you'd like to join us, it's free. Anyone can request access and come and join the community. And you've got lots of different members of the Ekahau team there and our amazing instructors. So if you have questions about something or want to maybe give some feedback or just keep up with what's going on and chat amongst yourselves, then yeah, do get yourselves signed up for the Ekahau Slack channel. Thank you very much, Jacob, for putting it in the chat as well. Okay, today's agenda then is going to be a bit of a mix of some theoretical stuff from myself around 6 gigahertz Wi-Fi. What is it? What the difference between Wi-Fi 6E and Wi-Fi 7? And then Kevin's going to be helping us think about when we plan to upgrade to a 6 gigahertz network and when we're in the redesign phase and thinking about more parts than just the Wi-Fi. So our access points, they connect to cables that go into switches, that go into firewalls, or going to then connect to your ISP. So there's a lot of things we need to think about when it comes to upgrading to 6 gigahertz. And we're really fortunate and lucky to have Kevin here with us today to help us with that part. And then at the end of the webinar, I will be doing some live demos in AI Pro Online and our optimizer to show you how you can take an old network that's maybe just 2.4 and 5 gigahertz, and then how you can transform that into a 6 gigahertz network, or just completely design a brand new 6 gigahertz network from scratch. And then you may be here thinking, oh, you know what, guys, I've actually already got a 6 gigahertz Wi-Fi network. Well, don't worry, we've got some content for you too. We're going to show you how you can actually optimize your existing 6 gigahertz network and ensure that it's running optimally for your client devices. Perfect. Okay. I like to just keep a bit of an eye on the chat as well, in case I miss anything interesting there. So do keep talking away. We'll be looking at that throughout the webinar. So let's first of all, maybe just take a look at where we are right now in terms of 6 gigahertz and the standard of Wi-Fi. So way that we kind of like to describe it is that we've kind of shifted from different eras throughout time. Initially, when Wi-Fi first came out, we was in the 2.4 gigahertz era with the likes of when 11B came out. Yes, we had 11A, but typically most of the devices back then, they were operating in the 2.4 gigahertz frequency band. And hopefully we know that in the 2.4 gigahertz frequency band, we have a limited amount of spectrum that we can use. And it's also heavily congested with non-Wi-Fi devices such as microwave ovens, Bluetooth, and other non-Wi-Fi devices that operate there. Fast forward a little bit later in time, and specifically, I would say around 2009 when we got 802.11n or Wi-Fi 4, is when we had quite a big jump into devices starting to move into 5 gigahertz. And I would say really that is when I felt personally a lot of enterprise networks were starting to not just think of Wi-Fi as this nice to have add-on guest network that we could provide to people, really making that shift towards Wi-Fi first connectivity and having much more devices connecting over Wi-Fi. So then over time, naturally, of course, we have more devices, they shift from 2.4 to 5 gigahertz. And the sheer amount of Wi-Fi devices there were in the world kind of meant that pretty much most networks you went to, you were suffering from some form of congestion. 5 gigahertz, we have up to 500 megahertz of spectrum. Depending on where you are in the world, that's going to give you up to 25 non-overlapping channels. And just, yeah, the sheer volume of devices on the network, 5 gigahertz was getting a little bit crowded, and we really needed to start to move into a new frequency band. And that's kind of when we move into what we're calling now this new 6 gigahertz era. And the first generation of Wi-Fi that is supported in 6 gigahertz is actually 802.11ax, which is the same as Wi-Fi 6. I know this can get confusing when I speak to some people sometimes. Wi-Fi 6, 802.11ax is the same thing. However, 802.11ax operates in the 6 gigahertz frequency band. That's what Wi-Fi 6E is. So I know a little bit confusing, but that's actually the first generation of Wi-Fi that's supported in the 6 gigahertz frequency band, and we don't have to support any of those older standards of Wi-Fi. And then now we are seeing lots of Wi-Fi 7 access points come around, as well as client devices. And they are Wi-Fi 7 operates in 6 gigahertz and is also supported in 2.4 and 5. So why would we want to upgrade to a 6 gigahertz network? Oh, in a nutshell, basically, it's going to provide the opportunity for you to really deploy an ultra reliable, highly efficient Wi-Fi network. We know Wi-Fi is business critical for all enterprises, whether it's a shopping center, an enterprise office, a warehouse, a cruise liner, you name it. Everybody wants to come and connect to Wi-Fi. And with moving into 6 gigahertz, you're going to have faster speeds, better efficiency, also increased security. Things like WPA3, management frame protection, is enforced for your authenticated networks in 6 gigahertz, and even your guest networks using open authentication is now at least encrypted with OWE. And let's be honest, the future of Wi-Fi is 6 gigahertz. So if you deploy access points that support 6 gigahertz, you're going to be future-proofing your networks. A nice way to visualize this additional spectrum is if you think about the 2.4 gigahertz, we only had really 80 megahertz of usable spectrum, which does translate to 3 non-overlapping channels, potentially 4, depending on where you are in the world. But trust me, just stick to 1, 6, and 11, 3 non-overlapping channels. Then in 5 gigahertz, 25 non-overlapping channels if we're using 20 megahertz wide channels. Then if you're based in the US, 6 gigahertz, you get that 1.2 gigahertz of additional spectrum, which would equate to 59 non-overlapping channels. So just from visually seeing that, you get such a sheer amount of additional channels that we can now use to reduce contention, less congestion, and have that really business critical, reliable network. If you're over here in the EU with me, yes, we only get 500 megahertz of additional spectrum, but we will keep fighting on, and hopefully we'll get access to that extra spectrum soon, one day. Other key benefits of 6 gigahertz is that there currently is a lot less interference. The non-Wi-Fi devices, things like microwave ovens, motion sensors, controllers, headsets, these started out in 2.4 gigahertz, and you're seeing a lot more of them now. They start to creep into 5 gigahertz and operate in there as well. So if you have lots of these devices, which actually I see them very often in lots of different deployments, these motion sensor security detectors and alarms and stuff, if they're operating in 5 gigahertz across some of your channels, you're gonna have to basically remove those channels from your plan if you want your Wi-Fi network to be not susceptible to interference. So we're moving into 6 gigahertz. Currently, there is not as many non-Wi-Fi interferers there. And also in 5 gigahertz, we have the DFS, radar, avoidance stuff that we need to think about. We don't have that with 6 gigahertz. So again, another benefit of moving to 6 gigahertz capable Wi-Fi networks. We don't support any legacy standards of Wi-Fi. So the oldest Wi-Fi standard we support in 6 gigahertz is 11AX, which is around 3 years old now-ish. So we don't have to worry about backwards compatibility with client devices that may be operating from 1999 or early 2000s, which is great. And the other benefit for moving, like deploying Wi-Fi networks that support 6 gigahertz is the more 6 gigahertz devices that you bring to your network that go into that 6 gigahertz lane, it's going to free up space in the 2.4 and 5 gigahertz lanes as well for your older devices, because I'm very aware that you may have devices in your network that just cannot yet upgrade to 6 gigahertz. If you think around that, the medical industry, you've got lots of medical devices that may operate on 2.4 gigahertz or maybe even 5 gigahertz that cannot yet be upgraded to 6 gigahertz. However, the more enterprise level devices like your iPhones, your iPads, your Macs, your Windows laptops, your Android phones and stuff, those devices that support 6 gigahertz, as they come into your environment and move to that lane, it's going to free up space in 2.4 and 5 gigahertz as well. So naturally, it's going to create less congestion for them, and you're going to have an improved performance for your older devices too. When it comes to security in 6 gigahertz, WPA3 and protected management frames is mandatory. And you go from using in WPA2 pre-shared key to in your personal networks using SAE, which is more secure as well. So enforces things like this, which means that your client devices are going to be more secure, less susceptible to be able to have that deauthentication attacks from people trying to get your client devices off the network. And it's going to make not only an improved Wi-Fi network, but a more secure Wi-Fi network as well. So lots of benefits for moving to 6 gigahertz. And then I wanted to talk about Wi-Fi 7 because even recently Cisco just announced, I think 2 days ago, their Wi-Fi 7 access points. HP Aruba have got their ones out. Juniper Mist, Extreme, Ruckus, etc., all have either announced or launched their Wi-Fi 7 capable access points. And even the latest iPhone 16 supports Wi-Fi 7. So if that's your kind of metric for measuring client devices and stuff on your network is Apple like me, then yeah, from iPhone 16 is Wi-Fi 7, iPhone 15 Pros is 6 gigahertz Wi-Fi 6. So what's new with Wi-Fi 7? So first of all, if we just quickly talk around multi-link operation, and effectively, if you think about a traditional Wi-Fi network before Wi-Fi 7, how that would operate is you'd have a client device connecting to an access point on its radio, but it'd be on a single radio. So if you connect on 5 gigahertz, you'd be having that communication on 5 gigahertz. With multi-link operation, there's a few different methods here, but you can effectively do band aggregation. So a Wi-Fi 7 access point and a Wi-Fi 7 client device can actually connect over multiple radios and multiple frequency bands. So 5 and 6 or 2.4 and 5 or 2.4 and 6 and aggregate traffic across multiple links. Also, it can do things like link steering. So if there's maybe you're connected on 5 gigahertz and then it notices that, oh, there's quite a lot of congestion actually on this 5 gigahertz channel, we should move to connecting on 6 gigahertz. You can actually do something called link steering. So that should make it more efficient for your Wi-Fi networks. We then have some new modulation. So 4K QAM. This effectively means that the complex modulation that we can use means we can transfer our data faster now. So we use a more complex modulation coding scheme to transfer our data. With Wi-Fi 7, we do get access to having 320 megahertz wide channels and marketed data rates of 40 plus gigs. Anyone here got a Wi-Fi 7 access point and a Wi-Fi 7 client device and seen anywhere close to 40 gigs data rate or throughput yet? No? Okay. Well, I have put a small table together on the next slide just to talk about what I think some realistic speeds are for Wi-Fi 7 and Wi-Fi 6E devices. And yes, Arturo using a 320 megahertz wide channel in Wi-Fi 7 on 6 gigahertz will give us just one available channel. So probably not likely to see it in the enterprise, but maybe at home if you've not got any neighbors yet occupying 6 GHz, you might want to do that. But I think probably out of all of the new features for Wi-Fi 7, I'm actually really excited about spectrum puncturing. And at a high level, what spectrum puncturing is when you're using a wide channel, let's say an 80 megahertz wide channel with Wi-Fi 7, if a part of that channel detects some interference, so maybe like 10 megahertz or 20 megahertz, that channel starts to become occupied or detects interference, instead of having to back off the whole channel, it will just communicate around the interference. So again, the high level tagline for Wi-Fi 7, it's going to be faster, you're going to have lower latency, and it's going to be improved efficiency. So there is benefits for having Wi-Fi 7 networks, and especially with 6 GHz. So I mentioned I put together a little table here around some Wi-Fi 7 and Wi-Fi 6E speeds. And what I've done here is massively simplified some of the data from the website mcsindex.net. If you haven't checked this out, go take a look at some point after the webinar. And this is where you can see all the different generations of Wi-Fi, their capabilities, how fast they can go depending on many different factors. And a huge shout out to the people behind this website because it's so helpful and it's a great resource. So on the left hand side, we've got Wi-Fi 7, sorry, the standard, and the first row, 2 rows is Wi-Fi 7. It's also sometimes referred to as 802.11be or even sometimes as EHT, extremely high throughput. And then I've gone with the most complex modulation scheme that they can use, which is MCS 13, 4K QAM for Wi-Fi 7, MCS 11 for Wi-Fi 6, and 1K QAM as well. And then spatial streams. So I've gone with 2 here because most Wi-Fi client devices out there, your phones, your tablets, your laptops, etc., they are pretty much all going to be 2 spatial streams capable. Yes, you might have access points that can do 4 spatial streams, 8 spatial streams, 16 spatial streams, but most client devices out there are typically 2 spatial streams. So again, I'm trying to give you some real world practical examples here. Channel widths, I believe strongly, this is my personal opinion, the 2 most popular channel widths moving forward into 2024 and 2025 and beyond is going to be 20 megahertz wide still for 2.4 and 5 gigahertz networks, and then 80 megahertz wide for 6 gigahertz networks, especially if you are over in the US. So that's what I put here. And then the maximum data rate that a Wi-Fi 7 2 spatial stream device can do on a 20 megahertz wide channel is 344 megabits per second. And then a Wi-Fi 7 device on an 80 megahertz wide channel can do 1.4 gigs effectively, data rate, 1,441 megs. If you compare that to a Wi-Fi 6 client device, it'd be 286 on 20 megahertz wide and 1.2 gigs or 1,200 megs on a 80 megahertz wide channel. Now I can actually show you this if I break out of my presenter mode. I'm currently connected to my 80 megahertz wide channel. I'm on 6 gigahertz and I'm doing 1,200 megs. If you were interested in that, don't know if you were, but I wanted to show you anyway. The reason why I want to show this is because you see lots of marketed data rates, and we're going to be talking about when we plan the rest of the network and switches and cabling and stuff like that, because one single client device associated on an access point at 80 megahertz wide can technically do over 1 gig now data rate. But if you have, let's say, 10 devices connected all doing this data rate, then you could potentially see quite a high amount of data rate needed or throughput needed for your client devices through to from your access point through the rest of your network. So on that note, Kevin, why don't we start to think about other parts of the network and how we can avoid some of those common pitfalls for when going up to 6 gigahertz.
Yeah, thanks, Matt. So how many of you guys out there have a boss or leadership in your career that has said, there's a new thing out, whether it's AI or the cloud or now Wi-Fi 7. I don't know how it works, but just get it done. Just have the APs installed. We want Wi-Fi 7. We want it, we want it tomorrow kind of thing. For me, it's definitely happened in my career a few times where I've had leadership not really understand what's required for the upgrade. They just want the upgrade and they want it now. So it was important to me to come up with some common pitfalls of some infrastructure things that we have to do before we can even get to a point where we can start thinking about implementing Wi-Fi 7 or 6E. So for instance, I have broken down to infrastructure planning. Cabling is going to be a big issue. PoE is going to be a big issue. Can your Cat 6A, Cat 6, Cat 7, whatever, actually perform the needs you need to do? And then we have multi-gig switches. Man, before it used to be I could throw in a 1 gig switch pretty much anywhere and be good. And now you have to start thinking about multi-gig switches, and do they have enough multi-gig ports available and that kind of stuff for your environment. So it's going to be a lot for the infrastructure. Network redundancy is going to be huge. Not only for the environment, their switches having multiple uplinks with their connections, but being able to bond those connections to get more throughput for each switch to be able to handle these new APs is going to be huge. Legacy support. Oh, man, I want to get rid of 2.4 gigahertz so bad in my environment. There are so many IoT devices or just like legacy things that I cannot get rid of. And so when you're thinking about upgrading or you have leadership talking about, we want to get this done, you still have to think about supporting those old legacy devices, having APs that have tri-band instead of just, cutting it out completely. So next, performance management, QoS. I equate it to customers or users getting the keys to a really fast car. If you give them the keys to a fast car and they go to the highway, they're going to open it up. They're going to take all of the available bandwidth that you give them. So having a strong QoS, being able to police that a little better, not prioritizing Netflix and things that take off, all of your bandwidth is going to be huge. Bottleneck prevention or prevention. We will talk about this in the next slide too, but basically going through your environment and making sure that you don't have any bottlenecks, you don't have any uplinks that are completely saturated or just can't handle the bandwidth. And then the last one, realistic expectations. This kind of ties back to the question where you have to tell your leadership. They see that Wi-Fi 7 46 gig uplink or speed, and they go, wow, I want that, and they expect that to be delivered, and it's just not real. That's in perfect environment, standing right next to the AP in a vacuum in fairyland, and it's just not possible. So you have to tell users, tell your leadership what the actual expectation is going to be. So that brings us to the next slide about your assessing your infrastructure. And a lot of people in leadership will say, okay, so all you have to do is replace the APs, right? Just switch these out for Wi-Fi 7 access points, Wi-Fi 6E capable access points, whatever. And it's a lot more than that. You have to, as the engineer, go back and reassess your entire environment. Is your switch capable of handling it? Do the uplinks, do you have the right cabling? What kind of uplinks do your switches have going to their controller, to the firewall, back to the core? Everything is dependent. If you have a single bottleneck in your environment, that link is the one that's going to be saturated. It doesn't matter how fast your devices can go. It doesn't matter how fast your APs can go. If you have, 40 gigs of available bandwidth, but down the line you have a single 1 gig link somewhere, you're going to be bottlenecked the entire time. So you have to go through your entire environment. You have to audit every single thing, even your firewall. Can your firewall handle that much data? What about the IPS? Can it process that much data at one time? And then you're looking at your WAN. Does your WAN need to be upgraded to 100 gig? 400 gig? It can balloon very quickly, and needing to make sure there are no blocks.
Oh. Yeah.
All right. So I think what's cool about this slide, going over the different PoE requirements, is that you have a bunch of different manufacturers over here, all with different models, all requiring the exact same PoE requirement, PoE++. So, I mean, if you look at this, each one has a maximum data rate and up to Wi-Fi 7. And it just shows you how important PoE is going to be for this, and cabling, that your cabling can support that PoE++. That is the new standard if you want full availability of your AP.
Yeah, and I know some of you are probably looking at this thinking, oh, Cisco Extreme Ruckus, they all have Wi-Fi 7 capable access points out there now. But we really wanted to just show, even if you're going for a Wi-Fi 6E or Wi-Fi 7 device, is that the power requirements, if you want to have them fully operational, they will require PoE++. So something for you to bear in mind, just when we was looking at data sheets comparing the Cisco 9164 to the Aruba AP755, if you want to get the AP fully operational, including the USB port, you will need just over 30 watts. However, if the USB port isn't important to you, then just with PoE Plus, you will be able to power the AP and it'll be in full functional mode. However, with Wi-Fi 7 access points, they pretty much all need PoE++. So this is what is highlighting here. If you basically says without and with a USB device attached, if it's PoE powered, it's going to need 40 watts. If it's powering something by the USB port, it's going to need 51 watts. So what Kevin was saying earlier around planning for PoE budgeting for your switches is going to be super important. But also, Kevin, as well, before I flip to the next slide, is that cabling is going to be such a big thing to think about. I know people already put in here like the term like rip and replace for networks. A lot of people ask that if I take down my old APs and put up brand new ones, will that meet my Wi-Fi requirements? And it potentially might, but now you're going to really have to ask your stakeholder or customers like, what cabling do you have? Because maybe people in the chat could let us know, like, for your environment, do you know what kind of structured cabling you have? Is it Cat 5, Cat 6, Cat 7? Do you have Cat 8? Let us know in the chat if you know what you've got before I throw up the next slide. So people said mix of Cat 7, Cat 5, Cat 6, Cat 6, Cat 6A. That's interesting. People might be thinking as well, you know what, Cat 6 is that could be pretty good. Yeah, lots of Cat 6, Cat 6, Cat 6. So then, Kevin, maybe you can just talk about this table quickly.
Yeah, and this is actually a really great table. I want to screenshot this, or I have it saved, I guess. But if I were, if I was in the audience right now, let's screenshot this. Um, it's, we have new buildings coming up every day, and really, really old buildings in most of our environments. So knowing what kind of cabling is really important. And I'm super surprised by, how if you look at the slide before where the PoE++ is the requirement now, I'm really surprised by seeing Cat 7 is now going to be the standard. Before you used to be Cat 6, Cat 6A, whatever, you can throw it in there. And now we're having to upgrade, and this is a huge cost. Like cabling can be one of the number one costs in a refurbishment like this. And so having to go to Cat 7 means a lot of our environments are not going to be ready for it, and having to recable, rerun new cabling. So yeah, this was super good chart for me to have.
Yeah, when I was putting this together, I was really thinking about this because a lot of people do ask that question about just taking down their old APs and putting up new ones. But if you want to have your access point fully functional, then you're going to probably need to replace your cabling. I can see people in the chat saying that some particular model access points, they will actually operate even at 30 watts, but some of the radios might not be 4x4, they might go down to 2x2. So that's completely vendor specific. Different vendors will do different things with their access points, and effectively some functions won't be enabled. I think the first thing that usually gets shut off is USB port, and then some of the radios or some of the capabilities get turned and shut down. So it's just something for you to all think about for when we're planning for upgrading to Wi-Fi 7 and 6 gigahertz. It's just, thinking about the extra mile we're going for the rest of the network is so important. And Kevin, what do you do? I know you work in public sector. When it comes to like cabling your access points, what is it that you typically do? Do you run one cable to your AP? Do you run two cables to your access points?
Yeah, so as we say, look at the next slide. The new standard over the last couple of years has been running two cables, and we actually don't have many APs that are able to have two connections, two data connections. So what we've been doing in preparation for the new APs coming out is just having one dedicated for a console. So we have it running back, and then if we ever need to console into something, we don't have to get a ladder. We don't have to go up into the AP, take it down from the bracket, spend time doing that. We go right to the IDF. We have that cable already run that's going to the console port, and we can plug in there and get console access. But it's definitely more expensive to do that. But as you can see, with these new APs that have dual uplinks, they're going to come super in handy. Before, we've had to plan for outages where we have, two APs in an area for coverage. But with this, it saves some time. It saves some downtime there where we can have failover. And one thing I wanted to mention here is that when you have two connecting to two APs or an AP connecting to two switches, there are different APs can do different things with those. They can do active or standby, or active and channel bond those two connections. And when you're doing that, it makes the PoE a little more complicated. So when you have an AP running two different switches and they're active, they're going to be using, you have to account for that PoE usage. And if it's not active, if it's inactive, well, it's waiting for the standby, then you still have to account for that PoE, even though it's not currently using it, because you want to make sure that if it does fail, it can fail over and bring up all the radios. So that's one got you that I found when dealing with these two APs. But yeah, the redundancy is looking more like a distribution layer now. With dual homed, everything is dual connection. It's looking less like an access layer where you have a single connection anymore, which is, I don't know. I think that's cool. Less work for me. Less
I
things.
guess it just
Go ahead.
I was just gonna say, I guess just like, when it comes to that time to run cabling, it's cheaper to run two cables at the same time in the event that maybe you have a cable failure, something happens to one of the cables, retrospectively going in and trying to run a cable in a live environment, especially if you're in food catering or health, and like it can be really challenging to get access to run cables. It's such manual work, so that's why people are going with that preferred method now, for sure.
Yeah, and I saw a comment about running. You can run, what was it? The Cat 7 to your AP and just have 6 everywhere else to save cost. And you can do that, but I would not recommend it. The labor is one of the more expensive parts of it. If you're gonna run it, if you're gonna run the Cat 7, just do it anyway. Like,
Yeah.
eat the cost a little bit, because it'll save you more in the long run of having to rerun cables. And also, if a port dies on a switch or something like that, network gremlins can go into IDF and start moving stuff around, and inevitably you'll get an AP connected, and it'll be a mess. So keeping everything a standard, one cable standard, and just running it the right way the first time will save you headaches in the long run.
Yeah, I completely agree with that, and some great tips. People are making notes of some of your tips as you're going along, Kevin. I can see in the chat. So I wanted to give you a quick way of visualizing an outage when you can plan that in Ekahau. So what I've done here is I've effectively done half the APs in red, half the APs in blue, and planning for the red APs to go to one switch and the blue APs to go to another switch. And what you can actually do in Ekahau, which I think is probably one of the least known features or least used features in Ekahau, is you can actually plan cable lengths and cable runs using the cable note feature. So I basically just simulated having two cabs with two switches, running blue cables to the blue APs, running red cables to the red access points. And then what I've shown here on the left-hand side is all APs fully operational. And then what would happen if we was to lose half those APs with a switch outage, if we've gone for that salt and pepper approach. And you can see on the right-hand side, with losing the red access points, still pretty much all of that primary coverage that you would need there. But when it comes to designing your Wi-Fi network, thinking about secondary coverage and redundancy, not just from an AP perspective, but also from your networking perspective, cabling and switches is super key and important. Does anyone in here currently use the cable note functionality? Or was it just me that likes to draw pretty cables? I don't know.
Yeah, and now we're bringing up 2.4 gigahertz. Unfortunately, 2.4 is here to stay in most of our environments for at least the near future. There are just too many IoT devices that rely on 2.4 that can only do 2.4, and they're usually, like, at least in my experience, they've been devices that, security devices or some type of like HVAC or something that no one really touches. No one really knows that it's even existing until it doesn't work. And then you have to troubleshoot and try to figure out what the heck this device is. But there are a lot of environments where 2.4 is still around. So when you're designing your wireless networks, you still have to think about 2.4. You still have to keep that in mind and support the legacy devices, unfortunately.
Yeah, definitely seen that a lot. And then this is quite important as well, I would say.
Yeah, and I'm dealing with this in my day job right now because we upgraded circuits for some of our remote sites, and immediately as we upgraded, our bandwidth got sucked up, and we looked at the policy, and it's all Netflix. It's all video streaming. And so we're having to go back and implement stricter QoS because if, like I said, if you give someone the keys to a Ferrari, they will go 100 miles an hour down the highway. They can't resist. They will use every single bit of bandwidth they can. So you'll find people doing Netflix, 8K streaming, peer-to-peer, whatever they can get away with, they will do. So when you open it up and have, all this extra added bandwidth, having a strong QoS policy will come in handy and save you down the line.
And we was talking about this earlier, Kevin, but I think Netflix will get even more popular tomorrow with the Mike Tyson Jake Paul fight on and it being free and live on Netflix. And I think quite a few people are going to tune in to watch that. Well, what do you think in the chat? Who do you think's gonna win that one? Is it going to be Tyson or Jake Paul? Or do you not if you don't follow that boxing, that's totally fine. But it's quite an interesting one, isn't it? I don't want to derail the webinar too much. Maybe we can we can have the
Hey, no
chat. Uh, if we've all still got our ears fully intact by the end of the webinar, we can continue that conversation then, I guess. But I thought that was a nice little plug to it. Kevin, another thing that gets really overlooked, I would say, is the physical installation of the access points.
Yeah, and as a network engineer, I don't physically install anything anymore. I get the blueprints of the building. I mark down using the Wi-Fi mapping and all that kind of stuff, the Wi-Fi design, and then I hand that off to contractors or the construction people, and they install the APs, install the jacks, and all that stuff. And I don't know if you want to do the next slide. There's been many a times where I've come in to do the active survey afterwards and found this, an AP placed exactly where I told them to, but there's been additions and that have not been on the blueprints. There's been, duct run across, cage, some kind of interference, AC unit right next to the AP, that kind of stuff that can just kill your design. And so, and so going back and doing an active survey and looking for obstacles, looking for things that are exposed and causing interference is really important. And there are certain ways to get around that, such as using a drop mount, as I said in there, to lower it below the obstacle and that kind of stuff. And that's really important, especially with the new APs coming out.
Mm-hmm.
And scheduling downtime. And I say this all the time to my coworkers who are afraid of doing stuff, that you can't make an omelet without breaking eggs. And leadership has to know that. Users have to know that. If they want the newest things, if they want upgrades, they want to have stability in their network, they have to have some downtime. And scheduling that in your environment could be very, very difficult depending on your environment. If you're in healthcare, if you're in, like I have fire stations and police stations. I work for the government. So I have different things that really can't go down, but they have to. So it's balancing that, doing your change requests and having leadership back you up in that, but it can be very, very difficult. But when you're doing these upgrades and you saw how much is involved that could be involved in your environment doing these upgrades, you're going to have to tell leadership and management, let them be aware that things are going to go down, there are going to be outages.
For sure. So let's take a look at how you can use Ekahau to plan towards upgrading to a 6 GHz network, whether you've got an existing 2.4 and 5 network, or if you just want to completely design a brand new network from scratch. The two different approaches that you can take with Ekahau is based on either measured data or traditional predictive modeling. And I'm going to give you some live demos of both of that. But first of all, if you think about the path of if you've got an existing network, an aging network that's just 2.4 and 5 gigahertz capable, how do we plan to upgrade that using this method? Well, a redesign is always going to start with a survey. And with Ekahau, we have multiple different survey methods to collect the data. I would love to know in the chat, out of these 5 different options for collecting survey data, what is your go-to survey method? Do you do stop and go? Is it continuous? Are you an autopilot guy or girl? Do you love using Just Go? Do you do lots of outdoor surveys using GPS? What's your favorite? Okay. Continuous, autopilot, continuous. A few people saying Just Go. Okay. Auto. I love Just Go though. Yeah, interesting. Yeah, I mean, personally for me, I would say I have like 3 that's my kind of go-to, and that's continuous, autopilot, and Just Go. I think they've all got their time and place depending on your environment and the network that you're in. I don't really do stop and go too much because I want to be continuously collecting data. And if I'm doing an outdoor survey, I typically will actually still just import a map of the Apple Maps or Google Maps and then just still tell it where I'm going. But man, Just Go has saved my my bacon a few times recently, and I've been sent some really great examples of people using Just Goes uh, for generating the floor plan. A lot of times I'm seeing now people go to an environment, a facility that maybe they've got the floor plan for the main building or a few floors of the main building, and then there's been an add-on area, shared a staff building and somewhere else where they just didn't have anything like any floor plan. So the fact that they can now go and capture data about it and then design against it as well has just been really helpful for so many people out in the wild. Okay, well, that was fun to see what people like to use the most. There's a nice balance there. But I think autopilot was the winner, I would say. Okay, cool. So let's have a jump into Ekahau AI Pro Online and look at upgrading our network to a 6 gigahertz one based off measured survey data. So if you're not familiar with our new cloud landing page, I just wanted to give you a little bit of a tour on how you can access getting into AI Pro Online, because it does look a little bit different now when you first log into your account. You see all of our different apps up here. You have these tiles that you can either start a new project, continue where you left off, jumps into Optimizer, or go into insights to look at all of your projects. But what I want to do is I actually want to look at go into AI Pro Online. So I just simply click on that. It's then going to open and take me to here. And what I actually wanted to show you is a rip and replace scenario. So we've got a nice simple office here, and this is just pure measured survey data. So I've only done a survey, there's no walls drawn, there's no obstacles or anything like that. The access points, they are HP Aruba ones, and they currently just support 2.4 and 5 gigahertz. And that's what we see down here in the bottom. So typically, if I wanted to simulate upgrading to a 6 gigahertz or Wi-Fi 7 capable access point, what I would have had to have done is import this into Ekahau AI Pro, our desktop, scale, draw walls, update the attenuation of the walls to be accurate, to reflect what we've got on site, and then place the simulated access point. However, using this new methodology of just walking around with the Psychic 2 and then uploading it to AI Pro Online, we use our AI machine learning to understand how RF propagates in your space, and I can now plan for changes without having to do any kind of manual work like drawing walls and stuff myself. So what I can actually do is maybe I need to relocate this access point. Maybe I want to move it from here into there. I can literally just grab it, move it, and it's now I can put it into anywhere I want, and you can see the heat map changes and it updates in real time and purely just based off that real measured survey data, which I think is very cool. And if I decide actually, you know what, I don't want to install it there, I can put it back to its original location by hitting reset device and it will jump back there. But what I want to show you is simulating that rip and replace scenario. So what I can do is actually I can just come into here, grab all of these measured access points that we found, and then I can actually ask Ekahau to replace them with a different model Aruba access point, and perhaps I want to change it for the 755. So if I click on that, what you'll notice happen straight away, well, hopefully you saw that, but all of the APs swapped, and now we have 6 gigahertz simulated data, even just from 2.4 and 5 gigahertz APs that were there. So we can actually predict and show you what 6 gigahertz coverage is going to look like and see if this meets our primary coverage, does it meet our secondary coverage requirements? And also, do you notice on the left-hand side, we have the Wi-Fi 7 icons, so you can design for your Wi-Fi 7 APs. And I can, again, if I wanted to, maybe I don't want to have this access point over here. Maybe I want to move it to this location. I can still move the access points around and plan and account for changes in the space if I wanted to. Also, as well, what I can do is I can actually just delete all of the access points, and I could just design the network from scratch using whatever model AP, but we'll stick with Aruba because why not? And their 755 AP, and I can just come in and place my access point and just move it around wherever I want. And what you'll see is like these suggested locations that come up as well. So that's one method that we've got for designing and upgrading to a 6 gigahertz Wi-Fi network. Oh, sorry, you don't see any signal strength there because I've got it on secondary. And I can again like just move APs around and plan for where I want to place access points using this method. Or perhaps you want to just design a network completely from scratch, or maybe you haven't got access to the site yet to do a Wi-Fi survey. So what I can actually do is I can come into here, click on the new project, and let's call it Ekahau webinar demo. And that was in Norway. that site, but I'm in the UK, so let's pick the UK, and then I'm going to hit continue. And actually, I'm going to give you all in the audience a chance to choose what we want to design for. So I've got 4 floor plans here. They're all either PNG files or a JPEG file of a hotel or some different hospitals. So which one would you like me to use for our traditional method of designing? So we've got hospital floor plan 1, 2, or 3, or we've got an hotel floor. Okay, host plan 2, hotel, 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 H1, hospital 2. Okay. There's a lot of people putting in some options there. Okay. I think people want is either between is there a pub? I wish maybe if you send me a floor plan of a pub, a nice pub in the UK, we can go with that if you want. So I think a lot of people wanted either the hospital floor plan or the hotel. Kevin, you can have the final decision, this one or this one. What would you like?
I'm thinking hotel.
Hotel? Okay, we're gonna go with the hotel. So I'm going to simply hit open and it imports. And then the first thing I need to do is give it a scale. So I know I'm going to do something very bad here. I shouldn't use a door to set my scale. We should use something longer and proper and etc. etc. I agree. Don't do what I'm doing. When I go there, I would measure it, of course, but I don't have anything else to scale it better. So please don't judge me too much. So I'm simply I'm going to hit finish now because I don't have any other floors of the hotel. We're just going to design for this floor. But remember, this was a JPEG file. So I'm just importing a JPEG. And the reason why I want to highlight that is because I have a question for you all. If I was to draw all of these walls manually myself now, these outer walls and these interior walls and doors, how long do you think this would take me? Or actually, how long do you think it would take you in the chat? How long do you think this would take? Days, an hour, 80 minutes, too long, 20 minute, a friggin' day, an hour. Okay, so a lot of people were saying various times. Maybe we're finding out in the chat who gets paid by the hour here. Some people saying this will take a whole day to draw all of these. Okay. The reason why I wanted to highlight that is because now, did you see our wall detection has done? It's finished. It's looked at the floor plan and it's detected the walls. And now if I just simply hit place walls, all of the walls have now been drawn for me. And we picked this floor plan, it was completely random. And the reason why I want to highlight that is because if you had a CAD file or a PDF file that has the layers determined properly, we could have imported that, read those layers, and then drawn the walls for you. And we can still do that, of course. But I can probably count on one hand out of all of the hundreds or thousands of Wi-Fi projects I've worked on when I've actually got good CAD files that I can actually use. Most of the time, I end up converting either CAD, if I get a CAD to a PDF, PDF to a high-res PNG or JPEG like this. And this has now saved me a whole bunch of time. And of course, like we're making some assumptions here. We've drawn brick wall for all of these outer walls. If I click on this, you can see it's a brick wall. And then interior walls, it's a drywall. And look, we've even drawn the doors. That's pretty damn good, I would say. And of course, yeah, some of the things are not 100% perfect. Like probably not any walls here, but I can just come in and get rid of them. And I could add some, like it's missed these doors here. Great, fine, no biggie. But it's not going to take me any time at all really to come in here and update these walls and change a few things as and when I need them. So this is going to be a huge time saver for you if you're working off of PDF, PNG or JPEG files, which I personally think most of us probably are. Stop improving the workflows with charge by. You can still charge by the hour, but now you can just do something else instead, like watch Netflix whilst you said you was taking 2 hours or 2 days to draw these walls. Next thing that I would do is I would define an area. So I would tell Ekahau, hey, this is where I want to see the coverage, so I can move this area in and I can tighten it a bit to be just specifically around where I want to see the coverage. Or I can just ask Ekahau, hey, place these areas for me. And when I do that, it automatically snaps to my actual floor plan area. Again, I think that's super nice. And then the last thing that I would probably do quickly is just go to my exclusion area, come into here and just define where I don't really want to see the coverage, like this big atrium or courtyard. And once I've done that, I've now got my exclusion area defined. I can now come in and start placing my access points. So Cisco announced recently their Wi-Fi 7 APs. Why don't we design for Wi-Fi 7 in Ekahau? Because we can, and so can you. So I can just come in here, pick one of these Wi-Fi 7 access points. And then what you'll notice has happened is we have this thing here called an assisted planner, and it now says that there's 13 devices to be placed. And the thing that a couple of things I want to highlight about the assisted planner is number one, it's actually the algorithm is actually based on the specific AP that you're planning to use. So the suggested locations will change depending on which vendor AP and model AP you go for, which I think is really nice. The other thing as well is you can do it completely automatic, and we can place all of these APs at the same time if we want. Or however, I could come into here, place an access point in one of the suggested locations, and then maybe, well, the other thing I just want to highlight is like if I look around here, is like it's not suggesting to place the APs in the corridors, it's suggesting to place APs in the room, which I think again is really nice. Probably not put one in the lifts. I should have made that an exclusion area, but that's my fault for not drawing additional exclusion areas. But the other nice thing that our assistant planner does is if let's say, for example, I can't place an access point in this room for whatever reason, I can't get a cable there, I can't mount there, whatever. If I just place an AP next to it, the assisted planner will look at that, it'll recalculate and make more suggested locations for you. So it's kind of like it can be fully automatic, it can be semi-automatic, or you can just place APs however you want to meet your requirements. Or I can just go ahead and place all of them. And then, yeah, I would probably not put one in the lift. That might be a little bit tricky, but I blame me for that, not putting the exclusion areas there, which is what I would have done, and again in this stairwell. But you can see in just a matter of moments, we can now have a really accurate predictive model based on that traditional method of Wi-Fi designing, uploading a floor plan, setting a scale, drawing some walls, adding out areas, and then placing access points. And we can see this for our 6 GHz access points. And the other thing that I just wanted to point out, when you're doing this kind of simulation, the formula that is typically used by the software is that, and why like scaling is so important is because we use a formula that's called free space path loss. So effectively, if I just turn on this access point, what you see coming from this access point, there's a natural degradation from the radio as the transmission is powered out from the radio. It's going to degrade naturally over time and over free space. And what we typically do is we calculate that loss, but then we would also subtract the different levels of attenuation that you have throughout your building. So drywalls are 3 dBs here, doors, etc., etc. So we subtract the attenuation from the radiation pattern coming from the AP based off from that free space path loss. But in the real world, there's other things that happens to our RF waves, such as reflections and diffractions. So the radio waves will bounce off of materials and they'll bend as they pass through certain materials as well. To calculate reflections and diffractions is quite a complex thing to do, and it's actually on by default. So the heat maps that you're seeing is actually calculating from free space path loss, subtracting your attenuation values, and also doing reflections and diffractions. So I think that's a really nice thing that you can see here. So you can try this out yourself. If you've got access to AI Pro Online, the Wi-Fi 7 APs are live in there from today. So go and try Aruba, Extreme, Ruckus, Cisco, Wi-Fi 7 access points, and you can see them in Ekahau AI Pro Online and try it out for yourselves. Let me jump back to the cloud because I wanted to show you how can we optimize an existing 6 GHz Wi-Fi network. So we did a survey of a college recently, this one. So if I open this, if you're not familiar with what optimizer is, it basically is your little Wi-Fi expert best friend that can sit in your pocket, is a nice way of explaining it. So once you've surveyed your environment and you upload it to the cloud, if you push that data to optimizer, what optimizer will do is it will automatically analyze your specific network against your specific requirements and then give you step-by-step recommendations on ways that you can improve your Wi-Fi network. So in this example, we had actually played around with the network before we did the survey. So we made things pretty bad to see if we could find all of the issues with the environment, and optimizer provides us these cards. If it's green, we have no issues. If it's amber, some things we want to try and solve if we can. But if it's red, then we've got some big problems there. So if I click on that and we take a look at this, I can see even on 6 GHz, and let's just say we look at the second floor, you can see because of the access points, radios, transit power they're using, there's some big issues with secondary coverage. However, if we was to implement the changes that Ekahau is recommending, I can slide the slider and see the massive improvements it's going to make by implementing these. Not just like things like coverage and channel interference, because they did have quite a lot of channel interference here because it was using super wide channels. You can see that kind of stuff. But the other thing I like to point out with Optimizer that's really nice is we don't just look at, sorry, yeah, I can show you the channel widths here, like mixed channel widths and on 5 gigahertz and 160 megahertz wide on 6 gigahertz. Probably not what we want to be doing over in the EU. The nice thing about Optimizer that I just wanted to highlight quickly is the fact that we don't just look at the heat maps that you would kind of expect. We'll actually analyze how your network's configured. Is your SSID configuration in line best practices? Is it your security, your minimum basic rates, et cetera, and give you a nice table to see that. If you want to see the exact recommendations, you just click on view all changes and all of your different access points, all the different changes and recommendations you can see here. Download the report if you want and share that with whoever's going to be making the changes. And that's a really nice way of being able to improve your network. So I definitely recommend checking out Optimizer if you haven't yet. Okay, what else did I quickly want to mention just before the top of the hour? Our next webinar, last one of 2024. I can't believe it. How fast has this year flown by? The last one we'll be doing in 2024 is going to be a fun one all around troubleshooting Wi-Fi. Mac will be back. We're having Phil Morgan join us as well, who's one of our really established ECSE instructors. So if you'd like to sign up early, save your seat, you can scan the QR code and get yourselves registered. Kevin, thank you so much for taking the time out of your day to join us. It was really insightful to have. We obviously at Ekahau we specialize in Wi-Fi, but to bring someone on that does networking for the rest of the network and give it insights, I think is really valuable and definitely made me think about and like speaking with people when it comes to the rest of the network planning for PoE budgeting, cabling, finding that bottleneck is so insightful. So yeah, I'm sure everybody really enjoyed that today. And what was nice is I could see in the chat when you were talking, so many people were like, that's a great idea. I'm definitely going to do that next time. So Kevin, people were really enjoying that. And of course,
Come. Thank you.
thank you so much, all of you wonderful people, for joining us on the webinar today. Hope you enjoyed yourselves, and I look forward to seeing you on December 12th for our last webinar of 2024. Okay.
Yeah.
Bye, everybody.